So we can see two vertical glass tubes there, and we have a liquid filled inside, right? Inside we have the liquid. Surrounding here we have water at 0 degrees Celsius with ISO. It maintains the temperature to be 0 degrees Celsius, and the temperature here is maintained to be 40 degrees Celsius. Therefore, the temperature of the liquid is also 40, and here the temperature of the liquid is 0. The height difference you can see clearly. The height difference is what? 1.6 centimeters. So what can you just see? It's very easy. What you can see is when the temperature is increased from 0 to 40 degrees Celsius. Suppose this is not there. Suppose this is there. So we have this system. We are at 0 degrees Celsius, right? Now suppose forget about this. Here we have what? A height of 81.6 centimeters. Now we can think of this system heating up to this system, right? So having that idea, like, okay, when I increase the temperature of this liquid to 40 degrees Celsius, the height that it climbed is 1.6 centimeters. So we can use what? The equation delta V is equal to what? V naught gamma delta theta. What's the true expansion here? Delta V is the true expansion of the volume. What's that? 1.6 times the cross-sectional area A, right? So 1.6 times cross-sectional area A. Right. What's the initial volume you started with? This volume, which is what? 80 times cross-sectional area A, right? So, and times gamma. Gamma is the true expansivity, true volume expansivity of the liquid, times temperature difference is what? 40 minus 0, 40. So then we can see gamma is equal to what? 5 times 10 to the power minus 4 degrees Celsius per, right? When you simplify this. So that's the answer, right? Yeah. So now we have question number 47. Figure shows an infinite ladder network of 1 ohm resistors. If the equivalent resistance of this network between points A and B is capital R, which of the following is true? Right. So we have A and B here. We have resistance 1 ohm, and here we have what? 1 ohm, and then here 1 ohm, and then 1 ohm, and it repeats. This keeps on repeating. Now forget about this. What do I have here? 1 ohm plus 1 ohm plus something, right? 1 ohm plus 1 ohm plus something, and then I have 1 ohm here, right? So I have 1 ohm here, and then 1 ohm here, 1 ohm here, and something x. Suppose it's going infinitely far away, therefore the equivalent resistance here can represent that to be x. So here I have what? 1 ohm, 1 ohm. So 2 ohms plus something parallelly with 1 ohm. You know, like if you have like this, like 1 ohm and any number like 2 ohms greater than 1 ohm, right? So equivalent resistance is equal to what? 1 times 2 divided by what? 2 plus 1, 2 over 3 ohms. So if you have 2 ohms and 1 ohm parallelly, you get 2 over 3 R. So you can understand definitely that the equivalent resistance is going to be what? Lower than the lowest value of the resistance. If you consider parallel combination, so if you have a parallel combination, you can find the lowest resistance. The equivalent resistance of those resistances is going to be equal to what? Lower than, it's going to be lower than the lowest resistance. So here it's going to be lower than 1 ohm. Then can you see it's going to be what? A value here called Y. I can put a value called Y here for the resistor, the resistance. That is going to be what? Less than 1. This what? Less than 1. Right, so I have what? 1 plus 1. So between A and B I have a resistance is what? 1 plus 1 plus a value less than 1. So definitely resistance between what? A and B should be what? Greater than 2, because 2 plus something, right? And the resistance between A and B should be what? Less than 3. Should be less than 3. So the answer is going to be the fifth one. Very easy question, right?